We said there is upthrust which acts on the body, because of which the weight of the body reduces inside fluid. But how much is that upthrust? Who gives that? What is the value of upthrust? That is given by Archimedes principle. Okay, that is given by Archimedes principle. And what is that? It states that upthrust of the body is equal to weight of fluid displaced by the part of the body. This is Archimedes principle. What does it give you? It gives you the value or magnitude of upthrust, which is equal to weight of fluid displaced by the submerged part of the body. Okay. So that is.
सर आपने ड्राइंग बनाई
तो क्या था? Weight of liquid is mass of liquid displaced into gravity, which is equal to, in terms of volume, where V is the volume of submerged part of the body. समझ आए? Yes. ये होता है upthrust का फॉर्मूला. Then we also discussed principle of flotation. What is principle of flotation? Did we discuss principle of flotation? Okay. So let us say there are two cases of flotation. Body might be partly submerged and floating, or body might be fully submerged and floating. The third case is when the body is sinked inside. Okay, these are the three different cases possible. So first two cases are flotation cases. Ship will fall in which category? Flotation first one. So this is case 1, case 2, and this is case 2. Only 1-2 cases are cases of flotation, right? So what is principle of flotation? When the body is floating, upthrust acting on the body balances the weight of the floating body. Okay, upthrust is equal to during flotation. So during flotation, upthrust is equal to weight of the floating body. Okay. So then, what is upthrust? Therefore, Fv is equal to mg. Fv is equal to mg. So what is mg now? Weight of the floating body, right? So what is weight of the floating body? V rho g. Weight of the floating body is V rho g. And what is upthrust? V rho L. You can write here volume of liquid. Okay. Like this. Because this is weight of liquid displaced, right? So what is VL? VL is the volume of the liquid displaced by the submerged part of the body. Okay. So it can be written as volume of the liquid or volume of the submerged part of floating body. Yeah. Capillary flow where volume of liquid is placed. ऐसा है तो ये हो गया ठीक है so this is principle of flotation so what does it give you so G will be cancelled above V L O L equal to A into okay so in this chapter this is the only concept with this you can solve all the numericals mostly most of the numericals are solved using principle of flotation and Archimedes principle. Okay. So two cases के लिए what will be the general question? Can I erase this side?
Sir, in the left-hand side,
Uh,
W2 is the weight of fluid, right?
weight, apparent weight of the same body inside fluid. When you enter the swimming pool, you feel lighter. When you come out, your weight feels heavier. So why do we feel lighter inside the swimming pool? Because our body experiences upthrust due to water. Okay, so our weight becomes less, feels less. It does not become, it is what it is. It is W1. It is mg only, but we feel less due to upthrust. Okay. So what is our net weight? Net weight becomes W2, which is apparent weight, not real weight. It is apparent, perceived weight.
Sir, in this case, the force applied by the liquid or force applied by the liquid.
Fluid में liquid और gas भी हो सकता है. Like if the balloon is flying in air, floating in air, that time what is applying upthrust on balloon? Air. ठीक है? So upthrust is the property of fluid. Any more questions here? Any more questions here? So we'll discuss the two cases. Did we discuss center of buoyancy and center of gravity in the last class?
Yes.
Okay. So what are the two cases?
Center of gravity is the midpoint of the object.
Midpoint of the object where the weight acts. Weight of the object acts at
Center of the
center of gravity. Which weight? This weight. Weight in air. Okay. Whereas buoyant force acts on center of buoyancy. So in this case, center of gravity and center of buoyancy are same.
Equal.
But here, center of buoyancy will be below center of gravity.
Yes.
So it will be center of gravity of the displaced water.
Also center of gravity and points are same.
Center of buoyancy is the center of gravity of the displaced water by the submerged part of the body. You understand? So which will fall below the center of gravity.
It would be the same as 3 and 2 would be the same as 3 and center of buoyancy.
Yes, these two cases are same. But here upthrust is less than the weight of the body. Here upthrust is greater. Here upthrust is equal. Okay. So in the first case, case 1, that means greater than mg. And in the second case, FB is equal to n. These are the two cases. First and second case. Case one, case. Okay, I had explained the reason for buoyancy, difference in the pressure above and below. All that is discussed.
So the buoyancy also depends on the density of the instruments.
Buoyancy also depends on.
The density or the type of liquid which we are using.
Yes, exactly. So it is density, the type of liquid is there. So this will give you the formula. Greater than. So GG cancel away. Okay. In this case, you will get VL. Form. Maybe, let's not do this. This is actually making the calculations little confusing. So rotation mein, let's start with this. So what is this now? So you have rho L by rho. This is equal to what? V by VL. Yeah. ठीक है? अब लेते हैं केस वन. केस वन. केस वन में क्या है? VL is less than V. Correct? VL is less than V. है ना? तो this means V by VL क्या हो जाएगा? Greater than 1. है ना? So अगर यहाँ पे 1 V by VL will be greater than 1 in this case.
But what does sign mean?
Less than.
Person, besides
Implies.
in subscript,
In
B subscript you wrote services.
volume of liquid.
Okay.
Here. देखो, this is the volume of the full body. And this part, जो liquid के अंदर है, वो क्या है? It is volume of liquid displaced. लिखा ना था? Volume of liquid displaced by the submerged part of the floating body. The liquid displaced volume is less than the full volume of the body. So V by VL will be greater than 1, no? Numerator is bigger than denominator, so it will be greater than 1, isn't it? So if this is greater than 1, then ये equation में क्या हो जाएगा? Rho L upon rho will be greater than 1. मतलब क्या आया? Density of liquid is greater than density of the substance. तो इस केस में when the density of the body okay, is less than the density of liquid, तब वो partly submerged होगा, like ship. ठीक है? केस 2 क्या बनेगा यहाँ पे देखो. What is case 2? अगर इक्वल है तो क्या हो जाएगा? If VL is equal to V, तब क्या होगा? V by VL 1 हो जाएगा, है ना? This implies rho L upon rho equal to 1. इसका मतलब क्या हो गया? ये दो केसेस हो गए. अगर डेंसिटी ऑफ द फ्लोटिंग ऑब्जेक्ट इज इक्वल टू डेंसिटी ऑफ द लिक्विड, तो वो ऐसे फ्लोट करेगा. It will float by being fully inside the water. तो ये दो केस बनते हैं फ्लोटेशन के. ठीक है? तो ये वाला जो फॉर्मूला है, इसको तुम्हारे बुक में कैसे दिया है मालूम है? ये दिया है स्मॉल डी बाय कैपिटल डी इज इक्वल टू वी बाय स्मॉल वी, ऐसे दिया. देखो वॉल्यूम में दिया. तो ये वी क्या है? वॉल्यूम ऑफ सबमर्ज पार्ट. कैपिटल वी क्या है? वॉल्यूम ऑफ द फुल बॉडी, फ्लोटिंग बॉडी.
Sir, so this would be the same for case 3.
केस 3 के लिए ये लगेगा ही नहीं ना, ये तो फ्लोटेशन का केस है. केस 3 में तो ये डूब गया. केस 3 में क्या बनेगा? ये फ्लोटेशन का केस 1 केस 2 है. केस 3 इज व्हेन डेंसिटी ऑफ लिक्विड इज लेस देन डेंसिटी ऑफ सब्सटेंस. डेंसिटी ऑफ सब्सटेंस बड़ा होगा. कभी वेट इज मोर देन द बॉइंट फोर्स ना. वॉल्यूम दोनों केस में सेम है. ठीक है? ये वाला जो चीज है, ये जो वेट है, इट इज ग्रेटर देन बॉइंट फोर्स. ये क्या हो जाएगा? यहाँ पे ग्रेटर हो जाएगा ये साइड. और VL विल बी इक्वल टू V इन दिस केस. जो सेकंड केस में, सेकंड थर्ड केस एक ही है इन टर्म्स ऑफ V. तो क्या हो जाएगा? डेंसिटी ऑफ द ऑब्जेक्ट इज ग्रेटर देन डेंसिटी ऑफ द लिक्विड. सिंक हो जाएगा. लिक्विड का डेंसिटी ज्यादा होगा या इक्वल होगा तब तक फ्लोट होगा. जैसे लिक्विड का डेंसिटी कम हो गया सब्सटेंस से, वो सब्सटेंस डूब जाए. इसलिए आयरन ब्लॉक विल नॉट फ्लोट, whereas wooden block will. समझ आया? आयरन ब्लॉक विल सिंक क्योंकि उसका डेंसिटी वाटर की डेंसिटी से ज्यादा होता है. फिर भी शिप क्यों फ्लोट होता है?
Because उसमें ज्यादा
Yes, yes.
air store है.
वो हमने डिस्कस किया था लास्ट क्लास में. हाँ, तो अभी हम वो करेंगे. ठीक है? So this VL is also volume of immersed part of solid. या तो वॉल्यूम ऑफ लिक्विड डिस्प्लेस है या फिर वॉल्यूम ऑफ इमर्स्ड पार्ट ऑफ सॉलिड या सब्सटेंस. ठीक है? चलो, everybody come on page number 73. We'll discuss application of principle of flotation. Can I erase it? Application of principle of flotation. So first application is flotation of iron ship. This is the first application. Flotation of iron ship. ठीक है? So what is density of iron? Greater than density of water. So will therefore iron block float in water or sink in water? Therefore, iron block will sink. Sink. But What is ship? This is a solid iron block. It is hollow from inside. Yeah. But ship is hollow. From inside. So if you consider a ship, right? Let us say this much part of the ship is below water, right? So this is the part small v, and the full volume of the ship is v. So what is the density of this volume? जो v है, small v वाला volume of ship. Will it have only iron? क्योंकि आयरन तो सिर्फ आउटर बॉडी में है, वो वॉल्यूम में एयर है जो अंदर है शिप का, पानी के अंदर जो वॉल्यूम है. बट हाउ मच लिक्विड इट हैज डिस्प्लेस्ड इक्वल टू दैट वॉल्यूम. सो उसका वेट विल बी मच मोर देन द वेट ऑफ द submerged portion of the ship as well as the entire ship. Weight of the entire ship is actually less than the weight of the water displaced by the submerged part of the ship. Understood? नहीं समझा. देखो व्हाट इज, सो यहां पे क्या निकालना पड़ेगा? आयरन का डेंसिटी नहीं चलेगा यहाँ पे क्या होगा? एवरेज डेंसिटी ऑफ शिप. एवरेज डेंसिटी ऑफ शिप क्या होगा? एवरेज लिख देते हैं यहाँ पे. डेंसिटी का फॉर्मूला क्या होता है? मास अपॉन वॉल्यूम. सो व्हाट इज द मास? मास ऑफ आयरन जिससे पूरा शिप बना है, प्लस मास ऑफ एयर. मास ऑफ शिप इज mass of iron plus mass of air in the volume of the ship divided by E. Total volume of the ship is this. So full ये solid block नहीं, okay, and this average density of the ship is found to be less than density of water. ठीक है, then density of water. तो वाटर का डेंसिटी शिप के एवरेज डेंसिटी से ज्यादा हो गया, तो फ्लोटेशन का कौन सा केस बनेगा? केस 1, पार्टली फ्लोटिंग, क्योंकि ये डेंसिटी ऑफ शिप इज लेस देन डेंसिटी ऑफ वाटर. तो शिप पूरा थोड़ी ना डूबेगा, सेकंड केस के जैसा फ्लोट नहीं करेगा, नहीं तो पूरा शिप तो अंदर डूब जाएगा. ठीक है, ऐसा हो. दिस कैन बी इजीली वेरीफाइड एट होम. If you have an empty bucket, when you lift the empty bucket, what is the weight of the bucket? Hardly any. Now fill the entire bucket with water, or even half fill it. Even a half-filled bucket weight is much more than the weight of empty bucket, obviously. So when you try to submerge the bucket, empty bucket, the amount of water it is displacing is actually equal to the water which it can hold. So that weight is so much heavier. So as per Archimedes principle, the weight of the force upthrust applied by the water is equal to the weight of the water displaced. इसलिए the bucket is not able to sink. You can judge for yourself. Even like 1/3 bucket full of water will be more than the weight of the entire bucket. क्योंकि bucket के अंदर खाली bucket में क्या होता है? Air होता है. इसलिए density of the bucket along with the air it is holding becomes less than the density of the water. Clear? That's the principle why ship floats like this. Clear? So the flotation of iron ship. It's not solid iron, that's why it floats.
Sir, but if, as you said, that if we put empty bucket into water, it will not sink. But if we apply force to it, it will sink.
Yes.
Yes, but if a ship is carrying cargo, that
So the weight of the cargo plus the weight of the ship is completely balanced by the upthrust. What this? देखो ship में क्या होता है? Ship is not a solid block, no. It is hollow from inside. So let's say तुमने कार्गो यहाँ बेसमेंट में रख दिया, ठीक है? इसमें कैबिन्स होते हैं, लाइक ये जो रूम बनाया है, इट्स नॉट अ सॉलिड कंक्रीट ब्लॉक, ये तो एयर है ना पूरा। तो ऐसे ही होता है शिप की, शिप में अगर बिल्डिंग भी बनी हुई है तो फ्लोर है, बट देयर इज एम्प्टी स्पेस, उसमें तो एयर है। एंड ह्यूमन भी आल्सो वी आर नॉट सॉलिड बीइंग्स ना, वी आर सॉलिड बट इन अ कन्फाइंड स्पेस। बट अगर इसको मैं पूरा वाटर से भर दूं तो उसका वेट कितना हो जाएगा? बहुत ज्यादा हो जाएगा। तो तुम कितना भी कार्गो फिल करो, तो कार्गो का एक लिमिट है कि इतना जो वॉल्यूम है पूरे शिप का, ठीक है, और जो कार्गो कार्गो का वेट है वो सारा कैलकुलेशंस है। इट कैन नॉट बी मोर देन। सो शिप एक्चुअली कैसा होता है? बहुत बड़ा होता है, ठीक है, लेकिन तुम कार्गो कैसे लेते हो? पूरा थोड़ी भर देते हो, एक डेजिग्नेटेड एरिया में ही भरते हो कार्गो, लेकिन वॉल्यूम तो कितना डिस्प्लेस कर रहा है? समझ आया? वो शिप का डिजाइन ऐसा होता है कि द अपथ्रस्ट ड्यू टू द वॉल्यूम ऑफ वाटर डिस्प्लेस बाय द शिप is much more than the entire thrust loaded in the ship, including the weight of the ship. वो तो इंजीनियरिंग है ना पूरा, शिप बिल्डिंग, इट्स अ कंप्लीटली डिफरेंट इंजीनियरिंग। वो सब कैलकुलेशंस के साथ होता है, ऐसे थोड़ी डूब जाएगा। और जितना उसका लोड बेयरिंग कैपेसिटी है, जो शिप डिजाइन करते हैं उससे 50 to 80% ज्यादा कैपेसिटी के लिए डिजाइन करते हैं। मान लो शिप में जो ऑफिशियली अलाउड वेट है कितना, 100 टन, तो शिप डिजाइन होता है 200 टन के लिए, समझे? तो हम कभी भी उसको ओवर कैपेसिटेट नहीं करते, वी ऑलवेज अंडर लोडेड। शिप में एक लाइन पेंटेड होता है ऐसा, उसको बोलते हैं प्लिम सोल लाइन। क्या बोलते हैं? प्लिम सोल लाइन। लाइन,
अगर शिप उससे नीचे गया तो फिर डिस्टर्बेंस।
हाँ, नहीं डूब जाएगा। सो किसी भी हालत में जब तुम लोडिंग कर रहे हो शिप का, तो ये जो लाइन है ना, वाटर लेवल उससे नीचे रहना चाहिए, प्लिम सोल लाइन के ऊपर नहीं आना चाहिए, फिर तो डूब जाएगा, ठीक है? बस कभी कभी ये शिप क्या होता है, क्योंकि नीचे से थिन होता है ना, तो ऐसा ऐसा रहेगा। If sea breezes are flowing, then it will topple the ship, क्योंकि उसका जो सीजी है, सीजी कहाँ पे है? सीजी मिड में होना चाहिए, तो वो बैलेंस रहेगा। अब जैसे हम भी सीधे कैसे खड़े हैं, क्योंकि हमारा सीजी विद इन द फुट है, वैली में है ना। तो अब तुम सीजी बाहर आएगा तो क्या लग जाएगा? गिर जाएंगे। सीजी पे पूरा वेट हमारा कॉन्सेंट्रेटेड है, तो हम ऐसा आगे थोड़ी देर तक ही झुक सकते हैं, as long as the CG is confined within the foot. Yes, और CG ये यहाँ से बीच में ड्रिल करोगे ना, एकदम सेंटर टू सेंटर, तो जहाँ पे इंटरसेक्शन हो रहा है, डायगोनल का इंटरसेक्शन मैंने बोला था ना अंदर, लेट्स से फ्रॉम टो टू द बैक साइड ऑफ माय हेड ऐसा, और वैसे ही इधर से वो जहाँ इंटरसेक्ट हो रहा है, वो बीच का लाइन, वहां पे हमारा सेंटर ऑफ ग्रेविटी होता है, तो दैट इज समवेयर इन द बेलियर वेस्ट एरिया। अब मैं ये आगे जा रहा हूँ, जैसी सीजी का है, इसके डायमीटर के सेंटर में, यहाँ पे नहीं है, बॉडी के बीच में है अंदर, तो वो जैसे ही वो पॉइंट टो को एक्सीड करेगा फिर मैं गिर जाऊंगा। यू कैन नॉट बेंड, द मोमेंट सीजी गोस आउट ऑफ योर फुट यू विल फॉल। इसलिए जो ट्रक्स है, ट्रक्स जब वो टर्न लेते हैं, है ना, हाई स्पीड पे टर्न नहीं ले सकता ट्रक, लेकिन फॉर्मूला वन कार क्या है, क्योंकि उसका सीजी क्लोज टू द ग्राउंड है, तो बसेस का सीजी ऊपर हो जाता है, तो जैसे टर्न होगा, लीन होगा ना, सीजी बाहर आएगा तो टॉपल हो जाएगा, समझे? लेकिन फॉर्मूला वन कार का सीजी बहुत नीचे होता है, वो कितना भी बेंड हो जाए तो भी सीजी उसका दोनों टायर के बीच में रहता है, इसलिए वो टॉपल नहीं होता जल्दी, बहुत हाई स्पीड पे टर्न लेता है, समझा? बाइक पे हाई स्पीड पे टर्न उतना नहीं ले सकते, नहीं तो राइडर को क्या करना पड़ता है, ऐसा लीन होना पड़ता है, पूरा पूरा झुकना पड़ता है, सीधे बाइक लेके ऐसा टर्न करेगा तो गिर जाए, ठीक है? तो सीजी का बात। ओके, फ्लोटेशन ऑफ ह्यूमन बॉडी, तो फ्लोटेशन समझ में आ गया। फ्लोटेशन समझ आ गया? कभी फ्लोट करेगा जब कौन सा बॉडी फ्लोट करेगा जब उसका डेंसिटी या तो इक्वल हो वाटर के या उससे कम हो। इक्वल से ज्यादा नहीं हो सकता, मतलब डेंसिटी कैन नॉट बी ग्रेटर। ठीक है, चलो नेक्स्ट वाला क्या है? रोटेशन ऑफ ह्यूमन बॉडी। कई बार हम शिप में वेट लोड करते हैं टू ब्रिंग इट सीजी डाउनवर्ड्स। सीजी जितना नीचे होगा ना उतना बॉडी स्टेबल होता है, सीजी ऊपर होगा तो पलट सकता है। समझ गए? सेकंड,
तो उसको शिप को फोर्स चाहिए भी रहता है और ये भी चाहिए रहता है ऐसे।
हाँ
अगर
बैलेंस में चाहिए।
अगर अंडरलोड होगा
अंडरलोड होगा तो वो भी ठीक नहीं है, पलट जाएगा, हवा से पलट जाएगा। इसलिए इसमें थोड़ा लोड होना चाहिए ताकि शिप थोड़ा पानी के अंदर घुसो।
तो उसमें लोड ऐड कैसे करते
उसमें ये स्टोन ऐड करते हैं, सैंड बैग ऐड करते हैं, उसको एक्स्ट्रा लोड ऐड करते हैं अपार्ट फ्रॉम द कार्गो टू अचीव स्टेबिलिटी। ठीक है, इट इज ऑल्सो कॉल्ड बैलास्ट। क्या बोलते हैं उसको? बैलास्ट। सबमरीन में यूज होते हैं। ओके, फ्लोटिंग फ्लोटेशन ऑफ ह्यूमन बॉडी। यस, फ्लोटेशन ऑफ ह्यूमन बॉडी। तो बताओ, बॉडी कंसिस्ट ऑफ
gases
almost gases,
water
mostly water. 70+% is water. Then you have gas, and you also have bones, etc. Gas नहीं यार, water, bones, muscles. ठीक है, तो पूरे बॉडी का डेंसिटी तो मोर देन डेंसिटी ऑफ वाटर हो गया फिर। 70% वाटर है और जो एडिशनल डेंसिटी दैट एक्सीड्स आवर डेंसिटी। So by default, will humans float in water? Now, if you drop human beings in water, will they float or sink? Sink, because we have bone density which is much higher. Then how do we swim?
moving like that.
Filling in air in the lungs. एयर जितना ज्यादा होगा उतना हमारा रिलेटिव डेंसिटी फिर, मतलब रिलेटिवली our average density of human body decreases. So when the lungs are inflated with air, okay, lungs inflated with air, reduces the average density. With respect to what? Which helps in swimming. Which helps in swimming. ठीक है? So when we inflate our lungs with air, then our average density reduces. So where will it be easy to swim? In sea water or fresh water?
Sea water
Why?
because the density is
Sea water density is higher than the river water. So it will be even easier for us. Next, flotation of submarines. Now submarines are opposite of ship. Ships are supposed to be above water always. Whereas in case of submarine, you should have the control in your hand. Most of the times it stays underwater, but when you want, it should come on surface. So how do we sink the submarine?
adding water into the tubes on the sides.
Into the submarine. So submarine has something called as ballast tanks. Okay. So this is, let's say, a submarine. So you have here you have what is called ballast tanks. This is also ballast tank. So this is a very crude design. Okay, it is much elegant. So when the submarine is supposed to go down, that time these tanks are filled with water. Okay, water is sucked in. So the weight of the submarine increases. And then it goes down. Okay. If you want to bring the submarine up on the surface, then the water is flushed out through high pressure. Okay, with the help of high pressure, it is forced out. When the water is forced out, then this empty volume, the density now becomes less, and therefore it can raises up. Is that clear? So this is the concept of ballast tank in case of submarine. Flotation of iceberg. Now what about iceberg? What is the density of ice with respect to density of water? Floats. That's why the iceberg floats. But the problem with the iceberg is 90% or more is underwater. Well, that's why it's you say that what is visible is the tip of the iceberg. Okay, so then it's a disguise for the captain of the ship. So how far to navigate? Because the ship portion which is above water, a much larger portion is below water also, where the propellers are rolling. So if you are not careful, if you do not navigate through the iceberg via a safe distance, the propeller may collide with the iceberg. And it may cause crash or damage the ship, which is what happened to Titanic. It was a judgment error. The ship went and crashed into some hidden portion of the iceberg. Okay, so it's a disguise tip of the iceberg. So that's why what you have to do. So we were discussing why the iceberg floats, because density of ice is less than density of water. Is ice a solid or liquid? The density of solid should be more than density of liquid. Anomalous behavior. Okay, so the moment water begins to crystallize and become ice, its volume expands. Okay, mass remains same, but the volume increases. So therefore density decreases. Hence ice floats on water. Is that clear? Okay. So flotation of ice flow. When did we start?
2:45.
We still have time, right? 15 minutes. 15 minutes. 350 or 45? 240. Okay, flotation of iceberg. Density of ice is less than density of water. Hence, icebergs float. However, 90% or more of iceberg is below the water surface. It's one word, right? Iceberg.
Yes.
Okay? So why 90%? Because there is only slight difference in density. Okay, so it's not. If it was equal, then the ice will be fully below, but it's not equal. It is less. So thoda sa upar hai. Okay. Now a question: what happens when the ice melts? Will the volume of the sea level rise?
Yes.
No.
Let's say you have a glass of water. Do this experiment today. Put an ice cube and check whether the water level rises or not.
Sir, water level will.
You have a, listen. You have a glass, है ना? With like partly some portion remaining, and now you keep ice. Now note the level of water after putting the ice cube. Now ice will melt, and that is the last level. It won't go above. Understand?
I have seen, when I was looking some shoes or something, at that time,
Use also.
yeah.
Okay.
So at that time, the level of water was this, like, the level of juice was the same, even though ice was there.
Yes.
And when it melted, it was the same.
Yes, exactly. That's what I'm saying. Because when ice melts, it contracts. Because when it gets crystallizes, when it changes from liquid to solid, it expands. But during melting, it contracts. Okay. So only the additional volume only is above the water surface. So when it contracts, it's leveled down. So there will be no increase. So why the sea level will go up? Because of the melting glaciers. That water will flow down into sea. Hence the volume will go up.
Yes, sir, what is the difference?
Glacier and iceberg. Glaciers are on mountains. Like Siberia or the North Pole, etc. So glaciers are on the mountain, but icebergs are inside sea. Dono alright. Okay. Next is flotation of fish. What is flotation? How
Fish.
Fish.
flotation of fish? How fish floats?
Has, all with.
Gills.
Gills.
I
It
didn't.
brings water into the gills to sink down and it releases the water to float.
So it has what is called as bladder, swim bladder. What you are calling gills. Gills are to navigate. No?
Breathe, breathe.
Gills is for
Gills are to
breathing.
breathe.
Okay. So what is given here is swim bladder. So swim bladder is like a balloon, okay? So like a squeezed balloon. So from the blood, it sucks oxygen. So it inflates itself. Once it inflates, the volume of the fish increases. Once the volume of the fish increases, its average density reduces because mass to वही same mass, increase of volume, the density will reduce. And therefore, the moment it inflates itself, it comes up. Okay, again when it squeezes itself, it goes down. So play of density. Yeah? When the density is altered, then it can go up or down, just like submarine. So submarine we have to fill it inside. We vacate it or fill it inside.
Does that happen?
I will have to check with ship, fish. You'll have to speak to fish and know. That's what is given here. Okay. So when a fish has to rise up in water, read it on page 75. See the first bullet point. When a fish has to rise up in water, it infuses gas from the fluid into bladder. Which fluid? Water and so its volume increases. This increase in volume of water displaced by the fish, and so the upthrust on the fish increases, due to which the fish rises up. है ना? समझ आ गया?
Yes.
Okay. नहीं समझ आया. छोटा ऑब्जेक्ट है तो ज्यादा वॉल्यूम ऑफ लिक्विड डिस्प्लेस करेगा कि कम, तो अपथ्रस्ट कम होगा. अब इसका वॉल्यूम बढ़ गया तो लिक्विड का अपथ्रस्ट भी तो बढ़ेगा, तो डिस्प्लेस लिक्विड का वेट बढ़ जाएगा, मतलब अपथ्रस्ट बढ़ेगा. वही हो रहा है फिश के साथ.
ऊपर.
तो फिर फिश ऊपर आए, अपथ्रस्ट बढ़ जाता है. Think of it in terms of volume. Now rising of balloons. Rising of balloons. Balloons. LLA. बताओ बर्थडे वाला जो balloon तुम लोग घर में when you fill it with air, does it float? नहीं. But you have seen floating balloons also. What kind of helium or hydrogen? दोनों ही है, light है ना?
सर्वर हाइड्रोजन वाला इजीली फ्लोटिंग है।
Hydrogen is heavier or helium is heavier? Hydrogen is lightest. Hydrogen has only one proton, right? Lightest तो hydrogen है ना? Helium is next, heavier than hydrogen. So hydrogen is the lightest. Okay. तो दोनों में से कुछ भी गैस फिल करो, अब क्या होगा जो एटमॉस्फेरिक एयर है, okay, that becomes heavier in terms of density as compared to density of hydrogen gas. इसके लिए उस पे upthrust लग जाता है, ठीक है?
So the balloon becomes lighter and it's.
Exactly. Okay, that's the case. All right. With this, we now come to a topic called density. So we have completed everything about upthrust, Archimedes principle, flotation. That part is over. Okay. So funda is when the body will float. Yes, when the density of the body is either less or equal, but not more. More means equal. ठीक है? Liquid की density से body का density क्या होना चाहिए हमेशा less या फिर equal. More नहीं होना चाहिए. More is the case of sink. More हुआ तो डूब जाएगा. Yes.
सर 5 मिनट बोल रहे हैं।
क्या चीज density? 1 मिनट. Density तो किया है ना उसको. क्या है density? Mass upon volume. 2-3 फॉर्मूले इसके अंदर. So we are coming now to the last topic, which is density, relative density. So density is how do we denote density? Rho. It's read as rho. Okay. Rho or rho, whatever. How do you define density? Mass upon volume. Density is defined as mass of the object divided by volume of the object. So the most abundant substance on earth is water. So water का एक density तुम्हें याद होना चाहिए. Density of water is 1 unit. Only at 4 degrees Celsius. At 4 degrees Celsius. Density of water, this is the maximum density of water possible at 4 degrees Celsius. Okay, because it has least volume at 4 degrees Celsius. Water has least volume at 4 degrees Celsius. When you cool water, when you lower the temperature of water below 4, then it begins to expand till 0 degrees Celsius. Understood? As it crystallizes, its volume begins to expand. So this is the maximum density of water. That's why it is always at 4 degrees. In SI unit, this is serious unit. In SI unit, centimeter per cubic centimeter. It's not direct. Per meter cube. This also at 4 degrees. So what does this mean? This means if you take a container of volume 1 cubic centimeter and you fill that container with water, that water will weigh 1 gram. Mass of the water in a container of volume 1 cubic centimeter will be 1 gram. Likewise, mass of the water in a container of volume 1 cubic meter, meaning a container of 1 meter length, 1 meter breadth, 1 meter height. When you fill it completely with water, it will weigh 1000 kilogram or 1 ton. This is the significance. Okay. Then the next part is relative density. Relative density of a substance. The density of water is known to us, right? So when you compare density of any other substance with the density of water, okay, in comparison, the density of the substance becomes relative density. So it is the ratio of density of substance with respect to density of water. So it is given as density of substance to density of water. Okay. So if the relative density of substance is greater than 1, relative density, let us say, is greater than 1, then what is the density of substance with respect to density of water? Greater. So will that float or sink? Sink. So all substances with relative density greater than 1 will sink in water. Rest all will float. So it's an important parameter. The other significance of relative density is it can be experimentally calculated very easily for any substance. Okay. So once you know the relative density of any substance, you can actually find out the density of the substance just by multiplying the substance with the density of water. That's the significance of relative density. Okay. We'll explore more in next lecture. Do you have a class tomorrow?
No.
Okay. Bye-bye.
Bye, sir. जैसा उनके लिए पर इधर है सर ने वो दिया ही नहीं वो दिया तो सर ठीक है बाथरूम क्या बोली वो बाथरूम प्लीज मजा आ रहा है बहुत साल क्या वो भी लड़का ही था ऐसा भी नहीं कि लड़की वो के दौर आते से ड्रॉप हो गया मुझे को आपको बोलता है एक्स्ट्रा अच्छा हाँ तो पता है ये वाला इस पे दर्शक बात करके समझना ओ क्या है ये क्या है ये अच्छा Yeah. What else of your game called?
There are two rabbits. Not fifteen. This. And then we just open the eggs. Egg. No.
I got no those because I.
Oh, sorry. Sorry. I think I'm calling you guys.
I think. एक बार यहाँ पे मैडम के हाथ था।
Yeah.